Hello everyone, welcome to today's lesson on Pandas, one of the most powerful libraries in Python for data analysis. In this session, we will explore Pandas key features such as its data structures, that is data frame and series. Along with their use cases, Pandas makes it easy to manipulate and analyze data and is widely used in both academic and industry settings for tasks involving large data sets, statistical analysis, and machine learning. Let us dive into the basics. Just to put a formal definition around Pandas, it is a powerful Python library for data manipulation and analysis. It provides two main data structures, that is series and data frame. Series is a one-dimensional labeled array, while data frame is a two-dimensional labeled data structure, more like a table or something that you might see in your Excel or CSV files. So data frame is a uh, real world representation of those data in pandas. This library is used alongside other popular libraries like NumPys and Matplotlib for variety of use cases that requires data manipulation and other aspect of machine learning. Let us look at Pandas series. It is a one-dimensional labeled array and it can hold data of any data type, be it integer, float, string, anything. Important characteristics of Pandas series is it can be indexed with labels like what you see in case of dictionary. On the right hand side, if you see some code snippet, to import pandas in your Python code base, you have to start with import statement. You can typically everybody writes it like import pandas as pd, and series function of it is used to uh, have functionalities related with series. So if you are having a simple three numeric data point, say 10, 20, 30 in an array, we can have actually an array representation of it. And if you want to index it more like a dictionary, you can provide that with a keyword that is called index, as you might see even in the code here. So what will happen here is if you call pd.series, and this is a function call, so open and close brackets, in between the first argument is of your data. Here we have provided an list, and going forward we will see several subtle variation of it, where you can provide this information in several ways, including even loading this from external file systems. And here we are actually trying to demonstrate its dictionary like characteristics, where you can index the item by uh, certain key. So here we are using A, B, and C, right? So if you see, if you had created a dictionary with key A, B, C and value 10, 20, 30, then you could have called that dictionary and in a square bracket A to get 10, right? Similarly 20 and 30 using B and C. Here also you'll be able to get the value of these individual elements by accessing them through index. So you can simply call yes and then a square bracket A, B, and C. We'll actually going forward in upcoming slides, sorry, we will see several variation of how you can create a Panda series and how you can access it both um, with levels as well as without levels. So pretty simple, the most simple, straightforward, creating it from a list like what you are having 10, 20, 30. Uh, pay close attention to this part, right, where you are having opening and closing list like notation, that is important. So you call pd.series on this and you have your actually series in variable s ready. If you print s, you will get like, now here if you see, since we have not provided any index, by default it uses numeric index. And so in this particular case on right hand side, if you follow my mouse, you see that 0, 1, 2 and their corresponding output 10, 20, 30, right, is labeled here. So whenever you are printing it, you will get the content of the list with the default index and the value of the series, and then it will actually be printing the data type of the series using d type. Now a similar thing, you can get it done through dictionary also. Again, you have to call pd.series. Look at the next example, and here, uh, uh, pay close attention to this dictionary notation using curly braces, right? The start of curly braces, and then we have actually provided key value in terms of a character a as 10, then comma character b as 20, comma character c, and then 30. So typically, this would have been your dictionary, right? With value A10, B20, C30, and you can straight away pass inside a PD series, PD.series, right? And here, if you see, you have actually your data set created. On the right hand side, if you see, if you're following my mouse, rather than having default 0, 1, 2 index as you saw in case of list above, you will have your indexes like A, B, and C, right? So your value of A is 10, B is 20, C is 30. Let's look at another variation of it. So we have created two, one through creating from a list, another creating from a dictionary. What is the common way of getting it? On pd.series function, right? Inside the bracket, you provide either a list or a dictionary. That's what that we have seen. You can even provide a numpy array. So that's what that you see in the third example, right, where you are importing numpy as np first, and then we are passing on np.array 10, 20, 30 to this actually pd.series function, right? What you will get here pretty similar to what you saw in case of list, right? So default indexing on 0, 1, and 2, and then your values at 10, 20, and 30. Advantage of this is that your D type has gone much down to int 32. Earlier it was int 64. So what we have done so far is we have introduced and given a formal definition of what Pandas series are. Then we have looked at it's a create interface where we have looked at three variation of it, from a list, from a dictionary, and from a numpy array. Now let us look at some of the common attributes of series. This will be needed whenever you are actually using it. Many a time you need to access this to get certain aspect of information about certain aspect of your data set, right? And since it is actually a first time introductory course, you have to pay attention and maybe repeat some of these several times so that you can make yourself comfortable about it. So the very first attribute is you can actually set, you can give a name to this series, right? And so in the previous series where we have created several examples, yes, right? The name of the variable was yes, and then we actually initialized it through a list, we initialized it through a series, we initialized it through a numpy array. Now we are just taking an example where we again repeat from the numpy array part, and if you print the series, the values are same. If you print s.name, you will get name of the series, which is example series, right? So you can see the the code below, right? S.name is example series, and if you print, then you get example series as an example. So the first one is name, right? So whatever is your variable, by using a dot and then the name of the attribute, right? So just to give you a quick overview, you have dot name, you have dot values, you have dot index, you have dot size, you have dot empty, and then couple of other less popular. So dot name is to get name of this particular variable, right? Name of this particular series. Values on the other hand side, you can access it just by simply calling values on the variable representing your series. So yes dot values, and for this particular one, what you expect? You expect 10, 20, 30 to be printed, and that's what that you see in your example here, right? 10, 20, 30. Then your index levels, if you see in this particular case, right, we have not provided explicit index, but we know that it is starting at 0 and then ending at 3, right? So basically what it is saying is, in this particular case, you can look at the intricacies of it. It is saying range index. It is storing its value in a range index, because indexes by default are contiguous. So actually it has chosen from 0 till 3, which is 0, 1 and 2, right? Had you given it name of the series like in the previous slide, right, A, B, C, so here you would have seen s dot index, where output would have been A, B and C. The number of elements, what is the length of this series, you can call size function on top of it, right? Since there are 3 elements, it will actually give you output 3. Now you can check whether the series is empty or not by simply calling empty on it, right? So we have looked at name to get the name of the series. Two more frequently used are values and index, where you can get what is the content inside that series. Index will give you how it is indexed. Size is to get you length of this, and check to see whether it is empty or not. Now, since you have already seen, right, in your previous lecture, that NumPy also supports multi-dimensional array. So in that context, what could be the comparison, right, between Pandas series and NumPy arrays? If you let us actually have an overview, and then we look at some example. So on feature part, right, we look at indexing, type of index, ordering of index, alignment, and memory usage. The most easy one, the last one, memory usage. Pandas series requires more memory. So this is a disadvantage with Pandas series. In case in your exam, if you are being asked in one or the other ways, which one is better or which one is good, have an eye around if there is anything being asked around memory. Pandas series, like list, is actually it is actually more memory hungry, right? NumPys are always the better. But on indexing side, NumPys are actually integer position. So you can only access them 0 based positioning, right? So from 0 to whatever number, either for indexing or for some other purposes. While as you saw in the earlier example, right, this particular one, right, the one from dictionary. So you can access 10 by using a square bracket A, S square bracket B, S square bracket C. So that's what it is talking about, that custom labeled index is possible in case of Pandas series, right? What are the index type? It could be numbers, it could be letters, but NumPy supports only numbers. Index order can be accessed in descending orders, right? So we can actually access our index from descending or ascending, while NumPy arrays are fixed and it starts with 0. Alignment. So if your data is not aligned, it means that one of the data set is having G different index, another data set is having G different index. So in that case, NaN values are generated for non-aligned data, while alignment fails if no matching values are found in case of NumPy array. So these are important requirement, where you saw that in indexing, custom labels are allowed in case of series, while NumPys are fixed and these are only integer position. Index type could be integer, could be letters. Index type for NumPy array is number only. Indexing order can be accessed in descending order, but NumPy is fixed and starts with 0. Alignment, if data is not aligned, NaN values are generated and still it will work. While in NumPy case, if alignment fails, in case there are no matching values, right? Memory users, definitely Pandas take more memory, and that's actually a negative characteristics here. Now looking at what we are talking about, right? Alignment side. So if you see, we are having leveled indexing and automatic alignment during operations. So if you're having a PD series, right, 1 2 3 with index ABC, that is S1, and if you're having S2 with BCD, so what is happening here? A and D are not aligned, right? So on top of this, if you are calling your mathematical operation S1 plus S2, it will actually generate NaN values for A, for D. BC will be added. BC, what was B? 2 here. What was B here? 6. So 2 plus 6, 8. What was C here? 3. What was C here? 5. Right? So you get 8. Right? And then your A and D will become NaN, because one of these value was NaN, and if one of that is NaN, then adding NaN to anything else will give you NaN. So you might be also be testing with an output code, and you should actually learn it, right? So it actually tries doing automatic alignment. Now on NumPy arrays, no levels, only positional indexing. That's what we are discussing. If you see here, array 1 or array 2, right? 1, 2, 3, and 4, 5, 6. If you add them, they will be added, right? And your output could be 5, 7, and 9 in that order. Now look at accessing series using indexing. So what we'll do is we'll be talking about what is the default indexing, since it starts with 0. So S0 will give you first element, right? Slicing, you can give range of it, right? So 1, 2, 3 means it will actually include 1 and 2, and it will not include 3 because 3 is exclusive. So if your Pandas series A10, B20, C30, then if you are printing it, your output is A10, B20, index 8, output 10, B20, C30, right? On the right hand side here. If you look at S0, S0 will be what? 10, right? Yes, 1, 2, 3, it will actually print yes, B, and so since your index here is actually non-integer, so in that case your slicing is AND inclusive. Keep this always in your mind. If you are calling S13, it will actually print even 3. Had it been actually 0, 1, 2, those kind of indices, then S13 would have only printed the second element. This is going to be very, very important, and you will be tested on this in your exam. Hope you got it. So just look at, if your PD series was A10, B20, C30, and in this case if you try and slice, this slicing should be familiar by now. We have seen it for string, we have seen it for list, we have seen it for numpys. It's again pretty similar. We actually provide an start, we provide an index, and in general what you have seen in case of list and others is last index, a last element, right, and is exclusive, that is not included. But what is the difference here is, if your series is indexed on characters, in that case and is included. So 1 3 will print S1, which is the second element, as well as S2, right? Now let's look at this access element using leveled indexing, right? So you have A10, B20, C30. If you print SA, you access by level, that is you get 10. And if you print from A to C, right? So then your levels are inclusive, right? So here you are going to get A10, B20, C30, right? So if you are indexing it by levels, right? Which is then actually your output is going to be inclusive. Okay. Now there are advanced indexing with ilock and dot lock, right? So if you see, if you want to access the first element on the series yes, you can simply call yes.ilock, and it will give you 0th element. If you give it a slice, here AND is exclusive from 1 to 3, it will give you output, right, which is actually in terms of your index as well as output. So B20, C30, right? When you look at access by label, again pretty similar. Here your AND is inclusive. So if you print your data from S A to C, you'll actually see this output uh, as you can see on uh, the frame below. We will visit this iLock and LOC again when we are actually talking about our data frames. Now, so we have actually so far reviewed creation of data series. Uh, we talked about how to create it from several sources. Then we talked about indexing, how we can access it by label, without label, and then we talked about another ways through .loc or .ilog. Now we'll actually move forward and move to more generic form of Pandas data frame, which can represent real world data set, that is data frames. So this can be created from various sources as it is, right? Now you know um, so in case of data frames, if you just visualize your tabular data, right? Or if you, in fact, actually, if you look at, pandas, right? So it's actually abbreviation is around more like panel data, right? And panel data is more like tabular data, right? So let us look at, and we looked at one variation of it, that was series, right? For pandas, you can have, uh, you know, uh, one or more columns, right? So say for example, you are having two columns, that is A and B, and say A is having two values, A1 and 2, and B is having two values, 3 and 4. What you see here is you can create your um, data frame in dictionary like structure, where you have provided dictionary, look at, pay attention to this, right? So data is a dictionary where key A is having a list of elements, key B is having list of elements, right? So all these keys will transform to your column name, right? And so it will be column A with value 1 2, with column B with value 3 4. And if you call pd.data on this data and print, you'll get your values as A12, B34, right? And 0 1 is the default indices that you see. Then from NumPy arrays, right? NumPy arrays, you can actually get your data. So what more like a nested list. So every individual column of data will be like one list, 1 2 3 4, right? So you got your data here, and you can provide data as one argument, but then you have to actually provide another argument in pd.data frame. So actually I think we are overlooking it. So in case of series, you got your series created by pd.series. Here in case of data frame, you have to call pd.data frame. And the first example that we saw, since it was having key value pair, those keys were automatically chosen as columns by data frame framework, or the package or module functionality. Now, when you are actually having no name columns, then in that case, explicitly you can provide it by say columns with this variable, right? So actually you get your data frame as list of list. You get your data as list of list from NumPy, and then to pd.data frame, you provide data as data, and then columns as the set of columns that you need. Again, if you call it, your output will be pretty similar. Another thing, say creation by copy, right? So df copy, you can call it as data frame copy, df.copy, right? And this also be having the same structure. So here in this particular case, for data frame, we introduce what exactly it is. Then we talked about its form, that was pd.data frame, that you can use in dictionary notation, NumPy notation, and several other notation. We'll see some of that in coming slide. Some of those were here, like just copying from another data frame using copy. All of these are a lot of index, a lot of new notion for you, primarily if you have not gone through any of the other pandas related course in your coursework. So only way for making it comfortable is reading through it and then executing code. In fact, we are having hands-on exercises for all of these slides, right? With different example, of course, just to ensure that we are having right engagement and not just repeating everything here. And you have to do more of that, right? So practice, practice, and practice to make yourself comfortable. From my side, what I can help you is, so far we talked about two data structures of pandas, series and data frame. We talked about how you can access them by calling on importing pandas, and typically the whole world import pandas as PDs above, and then using PD dot you can actually access the data structures, series as series, data frame as data frame. Then we looked at several ways of creating a series. That was through list, dictionary, uh, uh, through numpys, right? Here also for data frame we are looking at through dictionary if you are actually multiple column, right? And we saw that you don't explicitly provide the columns. If you are doing through now nameless numpys, you can provide columns by explicitly calling create inside the parameter column is equal to whatever it is, right? And then even you can copy to create another data. Hope this is helping. Let us look at some of the operations on rows and columns in data frame. So say in previous case, right, you are having your data frame DF created by either of these equivalent root, where we are having two columns A and B, and two rows 1 2 3 4. Now if you want to add a new column C, so there are several ways of doing it. One of that is you can simply on the df variable that you have got here, right? What variable you have got? Df, right? So you are getting df by calling your data inside period or data frame. Now on that df, you can actually give the name of the new column that you have in mind. Here we have decided C. So df, then the name of the column inside quotes, and then you can give the values, right? So you have given 5 6. Now if you print, you have got additional column created out here, right? And this will be reflected in your data. Adding a new row, right? So when you have to add a new row, now you have got how many columns? A, B, and C. So say that you want to add more variable like 3 4 and 7, A3, B4, C7. One of the ways by dictionary. So in dictionary you can actually assign key value pair to individual values that you are having, and then you can call append function in df, right? Now this is actually outdated, so we'll actually talk about extensions through other mechanism, but append is still actually accessible and it works. So what you do here, you give new row, right? Append new row, ignore index is by default it is set false. If you actually do ignore index equal to true, then will actually be not giving you errors related with indexing, because many a time when you are getting data set through several sources, there could be collision and indexes, and those might result in failure. So that's why this keyword is used, right? Printing data frame. Okay. Now, so we have talked about adding a row, adding a column. You saw it, how to do it. Now, if you want to delete a row, you have to call df.drop, right? You have to call what? df.drop, and then on df.drop you can provide, right, inside variable columns, right, the all the set of columns in a list. If you see here, we are having C in a list, right? So df.drop columns is equal to C, and you can actually have another thing that can call in place is equal to true, right? So you could have individual things out here, which could also say that so right, you can call in I'm seeing some issues actually on the screen. uh, so you can actually ignore it, but we can call in place is equal to true there, right? Okay. Another thing is, if you want to drop a column, you can do it by column. If you want to, drop a row, you can provide its index out here, right? And of course, you can use LOC, ILOC for that purpose, right? Now, either there are two notation. One is actually you provide your, uh, you know, uh, one thing is you provide your, after calling drop, you assign it to the same data frame, right? Or other data frame, whatever you have in mind. So in that case, otherwise you can use in place is equal to true. So you don't need to call this assignment explicitly, right? As you can see, with first drop of column, a C was removed. With second drop of index, third row was removed. Renaming rows and columns, so many a time we need to rename it. The technique for it, you need to call df.rename, and then you can actually have your columns in dictionary structure. So you want to call A as column, right? You want to call B or whatever, right? On the index side, if you want, then you can call index 0 as row 1, right? And so on and so forth. So if you print here your row 1 1, and then you are having your column from A as column 1, right? So what we talked about here is we introduced our PD data frame where creation can be done by df dot data frame. Now for creation we looked at uh, passing through dictionaries, numpys, list inside that function. We also looked at explicitly setting up the column name. Then we are actually doing some operation where we can add a column. We looked at the notation for that. We looked at how you can add a row. Then we looked at how you can delete a row or a column, and then we also looked at renaming it, where you have to call the so here you are having these are the functions. If it takes time, that's fine, right? So new column directly. Adding a new row, you can append. Deleting row, you have to call drop. Deleting column, you have to call drop. In case of row, you provide index. In case of deleting, in case of deleting column, you provide column. Renaming row and column, you can inside columns or index, you can actually a dictionary like a structure. Old new pair you can provide, and that should work. Okay, now let us look at accessing data frame elements the way we looked at series. So of course, first one is label based, right? So if your last example, see if this is what that you are left with, where column 1 and B are the columns, and row 1 and row is your data, right? Then in that case, you can call df.loc. So if you want to have label based, then you can call .loc, right? If you want to have label based, this is the difference that I wanted you to emphasize even in case of series. So wherever you are indexing by label, what is the label here? Row and 1, right? Say row 1, right? Then you have to call df.loc. If you have to do it by if you don't have to need to provide this, then you can call I. So you call df.log and loc, and then you call row 1, right? You can get it. Then you can actually provide it, right? In a slicing approach where you can actually give you say set of columns. So only you are saying that access column by label, right? So the first output where you are actually looking at LOC of row 1, that was actually your, what was your LOC of row 1? 1 and 2, column 1 1 and B2. That's the output that you are expecting, right? And when you are calling at LOC just by column 1, you will get what? 1, right? And if you look at all the rows for column 1, they are 1 and 3, right? Hope it is clear. Boolean indexing, so you can actually set up some logical operator. For example, if you want to filter rows where your column 1 data is greater than 1, so inside that df, right, and this notation you have to make yourself comfortable. If you call df column 1 greater than 1, right, so this is how you can actually filter all those data sets where column 1 is less than 1. Then slicing, if you want to do it, slicing on rows and column without level, you can use iLog. So how you get it? You are providing all the uh, rows, right, by 0 to 2, and then on column also you are providing it by 0 to 2, right? So rows and column both can be indexed without can be accessed without level, and if you're using level, you use LOC. If you're using index, you use iLog. If you're using position, you use iLog. This is very important. It will be tested on log iLog, right? Joining, merging, and concatenating, right? So say your DF1, right, is a single column data frame with value 1 and 2. So I've got it, using pd.dataframe, and inside a dictionary A12. Then you got DF2 with pd.dataframe inside A3 and 4. Now if you want to concatenate, you have to call pd.concat and provide DF1, DF2 in a list like a structure. So you can actually provide one and two and more uh, data frames inside a list for concatenation. And what you are expecting here, since actually column is same, so 1 2 you'll be having a vertical concatenation where you'll get your output as 3 4. It is interesting to see that somehow your index is 0 1 0 1, right? Think about it, how it will be indexed anymore, and what is the meaning of this index now, right? And how you can actually kind of make it 0 1 2 3. So hint is you can reindex. Merging, so if you have DF1, where you are having key A and key and A. So this is actually a column key value 1 2, column A value 3 4. Then say there another data with column key 1 2 and B 5 6, right? If you want to merge it, what you can call pd.merge, and it automatically sort of merge on common key. So here common column here was key, right? So key 1 2 A 3 4, and then it it's kind of, you'll get your B 5 6. So if you see the merging and concatenation, your additional columns coming on horizontally, right? And then you can do joins. So you can call df1 dot join df2, right? And here your indexes were AB in both the cases, and values were 1 2 and 3 4, right? So your A and B, right? You see A and B are joined, just like you have with merging, right? So now we have introduced another thing, query or concatenate, concat, merge, and join. Earlier we look at creation of data frame, and then several other attributes where you can actually add additional rows, add additional rows and column and delete them, as well as rename them. Let's look at again the way we did it for past example. We have two slides just to look at data frame attributes. This is very, very important, because day in day out you will be working with variety of data frames, and so you need to actually access them to know what all it contains. To access the columns, you have to call, assuming that df is the variable name of the data frame here, you have to call df.columns, columns. It will print you all the columns, right? Then to get row levels of your data frames, you can call df.index. To get the dimension of your data frame, that is row comma column combination, you can call df.save. To check if your data frame is empty, you can call df.empty. To check first few rows, you can call df.head, and you can inside you can provide n is equal to 2 5 1 whatever you want. By default it will print you 5 values. To check last few, you can actually call it tail, right? So here we have introduced some more data frame attributes, that is column, index, save, empty, head and tail. Columns, index, and save and empty is actually accessible like attribute, and head and tail as function. Now we'll take this example, forest area df, where we have indexed it by geographical area, very dense, moderately dense, and open forest. While our we are covering about three different states: Assam, Kerala, and Delhi. So we look at this forest area DF, and see that, keep this in mind when we look at individual output again, right? So data frame dot index, right? Which will be to display your row levels. So what are your row levels here? Geographical area, very dense, moderately dense, open forest, and your data frame as object, right? Then what will your columns will be? Your columns will be Assam, Kerala, Delhi, and then you will be printed with your D type object. Then the third one, where actually we are looking at D types, right? So he will show you individual data types, what output we get, the values. We'll see in the next slide what values will be, right? So values will be your, the central part of your forest area, right? 784,361 to 9.45. Then shape will give you, it is a 4 by 3, right? 4 rows, 3 columns, so 4, 3. And then what will be the size? Number of elements. That will be 4 into 3, 12. Right? If you call head n, right? So at least you are getting 2. Here in this case, if you're calling head 2, you get 2 head. What is the difference here? Look at geographical area and very dense, right? So these are the 2 head. What is the 2 tail? Moderately dense and open forest, right? So you get that by calling tail. So with this, we have come to some of the common things that we wanted to cover about data frame. Here we introduced what pandas can do, and we talked about its utility together with matplotlib and numpy. Then we introduced the core data structures of series and data frame. Then we actually provided introduction to .loc and .iloc for flexible indexing and slicing. What you need to keep in mind is use LOC when you do level-based indexing, which is when you provide some character or string-based index, and you do iloc when you have position-based indexing. Import export from CSV files. I think we have actually missed a couple of examples. We'll actually be seeing it when you do some other part of the exercise with data frame. And then we look at difference between and compare and contrasted our Pandas series with NumPy arrays. So we'll actually have some example around CSV updates, creation of our data frames through CSV. So far here in this particular case, right, we talked about our data frame. We introduced our actually series as well as the data frame one, and so basically we have covered the core concepts of Pandas, right, including data structure, how to import and manipulate data, perform aggregation. So actually to perform aggregation, handle missing value, visualize data, we have actually another slide, right? Not another slide, another presentation to be honest, right? So we will be covering that in the next videos, where we look at the other aspect of data frame around aggregations, visualization, connecting to SQL, right? And from Python itself doing operation on your tables. So stay tuned. Thanks for joining this. Do like and subscribe my channel, and see you in the next video where we'll actually talk more about aggregation, visualization, and other aspect of data.